Hello and welcome back to our video series on applying Newton's first and second law of motion. Let's take a look at number 4. A mass is constantly forced and accelerates to the right on a rough surface. Let's take a look. Please pause the video if you have not copied down the question. Okay. To indicate a rough surface, we can draw some diagonal lines underneath a horizontal line. The horizontal line, of course, represents the surface. A letter F can be drawn next to an arrow to show that there is a rightward force applied on this object. Now, what other forces could we sketch on here just to get an idea of what our free body diagram would look like? Well, you have the force that's applied. You have weight equals mg going down. You have normal force because you have a surface, thus you have a perpendicular force coming from that surface. And you have friction. We write the equation for friction. Friction equals mu times normal force, and weight equals mg, right? We write the formulas down for them. So these are our forces. Let's sketch them over here. Now, one thing to consider, one, normal force should balance the weight. They should balance. Why should they balance? Because they are the only two forces that are vertical, and since you're accelerating horizontally but not vertically, you need to balance the forces. Therefore, they are equal. So if we're drawing the force diagram for that, we make sure that we draw normal force equal to weight. Now, another concept that we need to make sure we're comfortable with is the idea that since friction is equal to mu times normal force, and mu is going to usually be less than 1, that means you're going to be multiplying a decimal less than 1 times the normal force. Therefore, friction is going to be less than normal force. That is a way to make sure that we draw our force diagram correctly. So we draw the friction equals mu times normal force. We're just drawing it shorter than normal force. And since we're accelerating to the right, we're going to draw the applied force longer. To match the fact that the applied force is the causing force of the acceleration. Therefore, it should be drawn longer. Since we are accelerating, we're going to be applying Newton's second law of motion on this problem. The formula we use for it, generically speaking, is causing force minus opposing force equals ma. The causing force is F because it points in the direction of acceleration, minus the opposing force of friction because friction opposes or is opposite to the direction of acceleration. And that's equal to ma. Anytime you have friction in a problem, please remember to substitute for mu n. Force minus mu times normal force equals ma. Then go one step further and substitute for n. Remember, n was equal to mg. So F minus mu mg equals ma. This equation satisfies the acceleration of an object being pushed to the right over a rough surface.